In this short little video, I'm going to show you several of the tools that we'll use in ELE 111, the Internet of Things. And in the SparkFun kit, it turns out we have a Arduino board. This one is not called Arduino, it's a red board. In the lab, we have a lot of Arduino boards. This is based on an Arduino design, and it looks very similar to the Arduinos that we have in the lab. And it turns out that if you take a look at this, it's got a power connector in this end. I don't know if you can, how well you can see it, this guy here. Over here is a USB connector, and that's how we get power from, we'll plug it into a computer and get the power for it for USB, via USB. It's got a lot of pins and a few other connectors on the end here. The pins over here tend to be the analog pins. They say analog in and power. Over on this side here we have digital pins and some more power pins here. And it turns out, if I take a look at my SparkFun Inventors Kit material that comes with it, here's a picture of the board, and eventually here they have much more detail, and they go over in detail exactly what the pins are. Down here, the various pins, and you'll see more of that. Sorry for the glare here. It turns out that, again, Arduino has been around for a long time, and there's a lot of knockoffs, and the SparkFun has what they call their red board here. So you're going to have some labs that use this device. It is a microcontroller, and you can take analog inputs and you can change them to digital values. You can take and spit out digital outputs out of the pins over here, and also power things with this. And that's one of the devices we'll be using. It turns out that another device we will eventually get to later on is this guy here, which is a Raspberry Pi. And the Raspberry Pi has gone through a couple iterations. This is a microprocessor, so let me just make it clear. This guy is a microcontroller. It has onboard memory. It is a standalone device. You can program it. Matter of fact, we can use Tinkercad to program it and simulate it. It'll run by itself. However, it's not capable of doing everything. And it turns out that, again, microcontrollers tend to be for controlling things. This guy here, the Arduino, is a microprocessor. And being a microprocessor, it actually was a standalone computer, except it's missing a few things, and one is its operating system, which you have to install, and you put in an SD card, and the SD card slides in here. Once it has an operating system, it can be connected through, say, an HDMI port over here to a monitor and a keyboard, a USB connection here, and we have a bunch of USBs and a RJ45 connection to go to the internet. The most recent version of this Raspberry Pi has onboard Wi-Fi and onboard Bluetooth. So this guy here, with a keyboard and a video display, plus the operating system, becomes a complete computer. Now it also has these headers. There's a header here, and there's a header here that needs special cables, but here you have a whole slew of pins, and those pins are able to take and be very similar to the pins over here on the Arduino-based type board, in that they're what they call GPIOs, general purpose interface pins, and it turns out you can send data into this device and send data out of it. So you can see that today's microprocessors and boards have shrunken the size down of a computer to hardly anything. And again, this microcontroller here, the red board, is not as small as it could be. But again, the headers are a way we get things into and out of. Again, in here, analog in, power over here, and digital out over here. And again, the GPI what they call GPIO pins over here for the Raspberry Pi. The Raspberry Pi also has looks like an audio connector over here, microphone and audio connector. So again, this guy here is a standalone computer basically. Single board computer they call it. Where this guy here is a single board microcontroller.